All right. Welcome everybody to AKS Office Hours. My name is Dave Strable. I work on our GBB team. For those of you who don't know me, if you attended previously, you probably know myself. What to expect on the call. So for anybody new, people that have joined before probably already know kind of how we run the call, but for anybody new to the call, we start with some AKS and ecosystem updates. And then we typically do a 40 to 50-minute session. Today will be on GitOps and Azure, specifically around the Flux v2 extension and the Azure Arc capabilities. So we have Chris and Johnathan from the product group that will speak on that. And then we try to leave, some time at the end, at least for kind of ask us anything related to AKS or, cloud native ecosystem, and also getting customer feedback discussion, things you're struggling with, things that are working well for you. So just keep in mind that it's really meant to be a two-way interaction. So just be mindful to stay on mute, but if you do want to come off mute, ask questions. You can also ask questions in the chat. We have a lot of people from the GBB team that can also help answer any of your questions. Recordings and content will always be available post-call. We try to make it available at least within 48 hours. If you have any thoughts, ideas, questions, if you ever want to present on this call, something you're working on, just reach out to us at AKS Office Hours at Microsoft.com. So for AKS updates, there's not a ton of updates, just because the last one we did cover kind of all the updates that we had at build. So a few of these, Azure Key Vault with private link with KMS is now supported. So that was what the support for KMS came out at, I believe, build. And yeah.
You're just sharing your PowerPoint like full size. I don't know if you're sharing the wrong screen. Like you're sharing I think you're sharing the wrong PowerPoint screen. Sorry. That's better. We can see that one.
Yeah, let me try this again.
Okay, no worries.
Maybe I'll just share my entire screen, even though that's risky. But let's try it anyways. Can you see it now, Alice?
Yeah, you're good.
Okay. So for the AKS updates, the Azure Key Vault with private link with KMS is now supported. The support for KMS came out, I believe, in preview at build, but now it will also support connecting to Azure Key Vault through private link. Preview of Kubernetes 1.24 also came out. There's also a AKS release tracker now. We'll put a link in the chat to that release tracker. That's generally available. So this allows you to see, because we do rollouts to different regions at different times, this will allow you to see like when that new release may actually hit your environment. So we'll put a link to that in the chat. Connectivity rollout is still continuing through May and expected to be completed by the end of June. I believe that's still on track. Azure Disk CSI Driver v2. So there's a preview for this. You do have to sign up for it. I'll also put that link in the chat. Probably one of the biggest features around the CSI Driver v2 for Azure Disk is going to be the improvement in pod failover. If you've used Azure Disk in your AKS environment, or just in Kubernetes in general in Azure, you've probably noticed sometimes it can take a little while for that disk to fail over. It's improved a lot over time compared to where we were even a year, 2 years ago. It uses what's called replica attachments. So essentially those replicas are ready to be attached when that, say, a pod fails over to a different node. So there's a significant improvement in that pod failover. You can use the replica attachments for anything that is LRS or zone redundant storage disk. There's also a feature in there. I've not seen a lot of customers use it yet. But there's a lot of parameters in there that you can set to tune the disk performance. So you can tune things like, for example, the queue depth of a disk. The other bigger feature is you can now resize those persistent volumes without any downtime. And the link is below, but we will put in the chat so it's easier to access. Some of the upcoming sessions, we have June 30th will be our quarterly AKS roadmap update with the product group. Then 2 weeks after that, we will have AKS security updates. So that'll be much more security focused in the roadmap there, and that will also be with the product group. Going into July and August, those are still to be determined. If you have some ideas, put them in the chat of things you may like to see. I think we may focus one of those specifically around storage. But if you have things that you would like to see on this call, please put them in the chat. So ecosystem updates. And I'll say there's not a lot of ecosystem updates because KubeCon Europe was just like a month ago. So there's not a lot. That is a horrible what happened on that slide. But KubeCon, Cloud Native Con North America will be in person, I believe virtual also, and that'll be October 24th through the 28th. So you can now register for that. I don't know how I feel about being in Detroit, Michigan in October. I usually like to go somewhere warm. CNCF certifications and training. There was a couple of new things that I saw that were interesting. They have a cloud native developer boot camp. It is self-paced, but they average if you 10 to 15 hours per week. You can complete it over 6 months. There's a lot of good training in there. You also get like a dedicated mentor during the training. There is a kind of significant cost to it. I think it was like $900. And at the end of it, if you complete the boot camp, you also get the Kubernetes certified cloud developer certification. They also released a new Prometheus Associate certification. The thing I noticed there wasn't a lot of like training they actually had around getting that certification. But definitely check that out if you're interested in doing certifications. And we will hand it over to our product group to talk about GitOps and Azure.
Yeah, hey folks, let me share my screen here. Let's see. Yeah, so hi, I'm Chris Sanders. I'm a program manager on the Azure Arc team. In particular, I focus on Azure Arc enabled Kubernetes, and in particular in that feature area, I focus on the GitOps. Johnathan?
Yeah, hey everyone. My name is Johnathan Innis. I'm a software engineer, also on the Azure Arc enabled Kubernetes team, working directly with Chris on Flux v2.
Great. So what we're going to do today is we're going to go through what GitOps looks like in Azure. That includes Azure Kubernetes Service and Azure Arc enabled Kubernetes. So sort of to kick it off, in the at Build, we announced the general availability of GitOps with Flux version 2 in AKS and Arc enabled Kubernetes. And also, let me know if anyone can't see the screen here. I make sure I'm showing stuff. Can someone see it?
Yeah, we can see it.
Perfect. I don't want to be talking to myself. All right. So yeah, we announced the GA of GitOps with Flux v2 in Azure, and a little bit of history. when Azure Arc enabled, so as far as the Kubernetes offerings in Azure, we have Azure Kubernetes Service, and then there's Azure Arc enabled Kubernetes. And Azure Arc enabled Kubernetes is part of the whole Azure Arc offering that Azure has to help customers with their hybrid work. So when you look at the complete Azure, when you look at the complete Kubernetes offerings, you have the managed AKS service, and then you have the Azure Arc enabled Kubernetes clusters, which are Kubernetes clusters that are somewhere else outside of Azure that you connect up to Azure, and then you can manage them. So when Azure Arc enabled Kubernetes released a year and a half ago, it included GitOps with Flux version 1. And it was basically built right into the install of Azure Arc enabled Kubernetes agentry at that point. Immediately, we started working on GitOps with Flux version 2. Notice in that first release that the Azure Kubernetes service did not have GitOps with Flux version 1. We had started on a private preview of GitOps with Flux version 1 in AKS, but then as soon as we pivoted to implement Flux version 2, we stopped the work on Flux version 1 in AKS because we don't want customers using Flux v1. We want them using Flux v2. And then what you see today in this GA is us actually releasing GitOps for the first time to GA in AKS, and also the update to the GitOps versioning in Azure Arc enabled Kubernetes clusters. So that's sort of a little bit of the history. The value that customers get by having GitOps as a managed service goes along with the same value with all of the extensions. And in AKS, there's the add-on capability as well, although the extension capability is also showing up now with Dapper and machine learning. The advantage there is that you get basically, the life cycle of the agentry associated with that service is through the Azure API. You get install status of the agentry, the health status of the agentry. You get Azure verified versions if you're using open source tools like we are with the open source Flux operator. You get automatic agent updates, and you get, of course, Microsoft support. So these are some of the reasons why we want to first class some of these open source tools like Flux. Just sort of to step back a second for those of you who are not really familiar with GitOps. GitOps is a methodology that's becoming quite popular in the Kubernetes community for managing the configuration of Kubernetes clusters and the deployment of applications to Kubernetes clusters. And the principle behind it are that you're going to use your Git repo as a source of truth for your system. So start thinking infrastructure as code, basically. And it's all stored in your Git repo. The Git repo is the single place where you have your operating declarations about how your Kubernetes cluster is going to be configured and which apps are going to be on it. All of the creates, changes, and deletes, for instance, that happen to your Kubernetes clusters happen first through your Git repo, through pull requests and merges. Because these, the state of your system is declared in YAML files, in Helm charts within your Git repo, that means that all of the changes to your Kubernetes clusters are observable. Every pull request and merge is versioned. You can see what happened from one version to the next, what changes were there. You can roll back. So it makes the auditing of changes in your Kubernetes ecosystem very straightforward just by looking at the version history in Git. And then within each cluster is the Flux operator. And the Flux operator has been configured to sync the Git repo on some frequent basis down to the cluster, and then apply the Kubernetes manifests. So basically, once you've done a pull request into the Git repo and it's been merged, then the Flux operator will automatically pull those changes and apply them automatically. There's no need for any person or any tool to actually access the Kubernetes cluster and do the deployments in the cluster. One other aspect of tools, GitOps tools like Flux, is that the agent that is running in the Kubernetes cluster is also continuously watching the state of the cluster and comparing it to the state that was declared in the Git repo. And if the cluster has drifted for any reason, the Flux agent will attempt to reconcile the cluster back to the declared state. So it acts also as a desired state configuration operator as well. So a lot of good reasons to go to the GitOps route, and this is one of the reasons why we decided to first class the implementation of the Flux operator, the CNCF Flux operator as our GitOps tool. So when you look in detail at the Flux 2 implementation, there's a couple parts to it. One is this cluster extension, the Flux cluster extension. As I mentioned, for Arc Kubernetes clusters and for AKS clusters, increasingly there's this new capability called the cluster extension. And this is how Azure services will be deployed to the Kubernetes clusters. The cluster extensions in Arc Kubernetes include Monitor and Policy and Defender, Flux, the data services, machine learning. There's a whole host of services. Anyway, it is becoming the way to get these services onto your Kubernetes cluster. In AKS, it's starting out with machine learning, Flux, and Dapper. I believe there is a roadmap for some of the other extensions also to be deployed that way. If you want to deploy right now Azure Arc enabled data services, you can Arc enable your Kubernetes, your AKS cluster, and install the data services into that AKS cluster as well. But when you install the Flux operator, you get the source, customize, Helm, and notification controllers. Flux v2 is a major update to Flux v1 in that it's become Kubernetes native, and it's based on controllers and CRDs. So it's very, in order to make our Flux 2 implementation similar to how customers used Flux 1, where basically when you implemented a Flux 1 and a Flux 1 config on your Kubernetes cluster, you defined a source, a Git source, and that Git source then would just be applied to the cluster. So with Flux v2, it's more open, but we decided on our side, when you make a Flux configuration resource against a cluster in Azure, you're required to define a source, which is basically a Git repo, and the path or the branch or some other identifier within that repo that can be used then to pull the manifest. So you define a source, and there's one customize that is defined. And a customize is basically just the controller that manages the deployments of the Kubernetes manifest, whether they're just straight YAMLs or whether they're customized, it doesn't matter. And then there's a brand new Helm controller. Helm is handled quite differently in Flux v2 than it was in Flux v1. And then there's a new notification controller. You also have the option, if you want, to install the image automation and image reflector controllers that Flux has. So secondly, once that extension is installed, then you can start creating one or more Flux configurations. And a Flux configuration is, you can think of as one instance of a Git repo that's going to be deployed, where the manifests are going to be deployed to the Kubernetes cluster. You can have multiple. You could have one Flux configurations for your application or for your Kubernetes admin teams to lay down all the baseline configs across all the clusters that are in your company, the baseline applications that are going to be used. And then you can have other Flux configurations, one for each different app team or one for each different business group and the applications they need to deploy. And then that would point to their specific Git repo and deploy their specific applications. So it really it enables the sort of multi-tenancy and the separation of concerns in Kubernetes between the cluster admin teams and the application teams. And we're looking more and more at models of companies who really want, the cluster admin teams to basically set up the clusters, do the core configurations, set up the CI/CD, and then they will delegate out just namespaces within Kubernetes clusters for the different app teams, where the app teams don't really need to worry about Kubernetes much at all. That's all for the admin teams to worry about. And the app teams focus on their applications. We see this pattern more and more as we talk to customers. One of the things we did when we worked very closely with Weaveworks over the past year and a half on our implementation of Flux v2, and one of the things we had them help with in the upstream was implementing a stronger multi-tenancy solution to Flux, and we have that on by default within our implementation. One of the new things that comes out of Flux v2 in their customizations is you can have dependencies between customizations where you can say deploy everything that's in, say, the infra folder first, and then once that's deployed, then deploy things that are coming from the apps folder. And so you can line up what should be deployed first and what should be deployed second. So with that, I'm going to just jump into let's see, quick some demos here. I'm just going to kick off just to walk through the UI, and then Johnathan will have some more in-depth demos. So when you're in Azure, as I mentioned, GitOps works in both Azure Kubernetes Service and Azure Arc Enabled Kubernetes. And this is totally in line with the desire for us to make the management of AKS clusters and Azure Arc Kubernetes clusters as similar as possible for customers. And GitOps is one area where we can make it exactly the same for customers. And if we look at, I'm just going to start with an Arc cluster here just to show you what it looks like if you go into an Arc cluster. And you'll see in the TOC down here, there's extensions. And you see we have the Flux extension, and there's a monitor extension. You can add more. And then there's GitOps. And in the GitOps area here, you see each of these are Flux configurations. And you see here the name of the configuration. You see, really importantly, this piece here called compliance. You see which namespace it was deployed to. You see the scope. In this case, it was a cluster scope. So all of the Kubernetes declarations for this configuration can be applied at the cluster scope. This state says that the installation of the agent tree succeeded. But importantly, this compliance here, we have implemented the Flux v2 wait feature, where we basically wait until every single Kubernetes object has been spun up and the status has been returned. So this compliance is the compliance of all of the deployments that are declared through this configuration and that source. And so this piece of information here, whether it's compliant or non-compliant, now can be used in Azure in things like alerts to tell you if the cluster is in compliance with the declarations in the Git repo for this particular configuration. Very powerful piece of information here. And if we dig into this configuration a little bit, again, we have the compliant state. We can see configuration objects, and I'll talk about that in a second. A lot of information about this cluster config. We can see here information about the source, that this was a Git repository. We also support a bucket source, S3 bucket source. We are currently working on first classing the Azure Blob Storage as a source, and also a container registry as source for GitOps. Here's the repository URL. Secondly, the branch that it's going to be in. There's other reference types that you can use, and I'll show you those in a second. And if we look at, and then we have a couple of the configuration objects here. These are all of the Flux objects that are in the repo. They are not all the ones that were created with our configuration. So applied by here, these 3 -- those are the ones that were actually configured in Azure, okay? But then you can see that these other Flux objects, a Helm release, Helm repository, these came from declarations in the Git repo. But these are all Flux objects that were created and that the different controllers will use. the source information here. Again, you can look at things like the reference type, and we've implemented all of the Flux 2 capabilities. You can use a branch, you can use a commit SHA, a reference tag, a semver range. You can use private or public. In this particular case, we're using public because this is the public demo repo. But if you choose private, then there's many different authentication options, SSH, HTTPS, and many options you can use there. And then finally, the customizations, and we defined 2. This all is in our tutorial, our initial tutorial in the Azure docs, where there's an infra path within that repo, and there's an apps path. And then we said that the infra depends on or that the apps depends on the infra being installed. Another thing that I enable is prune. What this means is that if I ever delete this customization or delete the config, then Flux will clean up all of the resources that were laid down in that cluster based on this config. So it's very useful. So with that, I think I'll hand it over to Johnathan.
Yeah, thanks, Chris. Let me go ahead and share my screen. Bring it up. Okay. Who can let me know if it's not big enough or if you can't see. But hey, everyone. Again, I'm Johnathan Innis. I am one of the developers on doing the integration with Chris on the Flux v2 integration in Azure for Arc connected clusters and for AKS clusters. So today we're going to kind of walk through a couple, like a initial scenario. We'll look what the onboarding experience looks like based on what Chris just described for a single configuration on AKS and like what it exactly looks like to get through installing the controllers, installing the configuration. And then we'll talk a little bit about how you can view this in like a multi-cluster way. So how you can bootstrap AKS clusters with Flux, with configurations on top of them, deploying that like very easily with infrastructure as code with Bicep. And very soon we'll have a policy support for onboarding and continually reconciling, deploying the Flux extension and Flux configurations on AKS clusters. So once policy is released, that will be kind of continuously enabled. But for now, we're going to show infrastructure as code and how you can achieve that. And then we'll talk a little bit about how you can use the Azure Resource Graph Explorer to view your compliance state of your configurations across different clusters, across like multiple subscriptions, say. So with that, I'm going to jump into the initial onboarding experience. So as Chris just described, there is a tutorial doc out here that describes kind of how you can onboard a configuration using the AZ CLI. We're going to walk through that experience. We effectively have a example repo that is based off of the Flux 2 Customize Helm repo. Here we have a few different directories. The ones that we're mostly concerned with are the apps directory and the infrastructure directory. So you can think of the apps directory as storing all of your applications that you might need to deploy to a cluster. You might be able to deploy different types of that application. Let's say you have different configurations for that application. So in this case, there's this kind of dummy pod info application that when you go to the cluster, it'll kind of bring up this pod info app. And there are some overlays on top of this pod info application that change things based on which environment it's running in. So you might have a different version for production. You might have a different host name for your ingress. These are things you can kind of overlay for the environment specific scenarios. And then from the infrastructure side, we are just looking at laying down some basic infrastructure components to be able to run this app on top of it. So again, if you're thinking about deploying applications on top of like just baseline infrastructure that includes like logging, ingress, in this case, a cache. These things need to be potentially laid down prior to your applications being spun up because the applications might have a dependency on these things to exist. So in this case, we're bringing down Nginx ingress controllers and some ingress definitions, as well as a Redis cache. And so the pod info is going to connect to this Redis cache. It's going to be available through the Nginx. It's going to run on top of that. And so these are kind of the two main directories we're concerned with here. So if we jump back into portal. So the basic command to deploy this application to the cluster is this az-k8s configuration flux command. And as Chris described, there's also a UI to go along with this, but we'll walk through the CLI right now. So here we're going to create the configuration in the Go example app resource group. We're going to deploy it to this Go example app AKS cluster. We're going to give it a name with this -n flag. And then we're going to deploy it to a given namespace. In this case, because of the multi-tenancy model, we're expecting some of the manifests in this repo to be deployed to the cluster config namespace. So we'll deploy it to that namespace. We're deploying it to a managed cluster. Managed cluster meaning an AKS cluster. And then we'll also give it a scope, which will be a cluster scope. We'll point it to the URL that we're interested in deploying to. So here we can just go into GitHub, copy the URL, and then paste that in here. Give it a branch. So right now we're going to be watching the main branch. As Chris described, there's different ref types, so you can watch different things. Let's say you wanted to pin to a certain commit or a certain tag and update as you go, you're able to do that. Right now we're going to pin to the main branch. And then we're going to describe customizations. So customizations being the apply paths from the repo that we want to deploy to this cluster. So here we are going to describe an infra customization, which is going to be deployed from the infrastructure path. And in this case, as Chris described, we're going to set prune equal to true so things automatically clean up as we remove them and add them. And then we're also going to describe a apps path, which in this case is going to be the apps/production path. And again, prune is going to be equal to true. And we're going to say that we want this application to depend on the infra customization. So here we've described the basic configuration that we want to bring on the cluster. So we can go ahead and run this command. And it's going to go ahead and do a couple things. So first of all, it's going to check on the AKS cluster whether the Flux extension has been installed already. If the Flux extension has not been installed, it's going to go ahead and provision that extension. So if we were to go look at the, so it's going to say an update is in progress, but if we were to go look at the workloads as the extension is getting installed, it's going to take a second for it to kind of deploy a couple things. So one, it's going to deploy the extension manager add-on to this cluster, which is going to bring down a couple components to manage the extension installations. And then secondarily, it's going to bring down the Flux extension. So once it brings down the Flux extension, as Chris mentioned, it's going to install all of the controllers that are associated with the Flux extension, which include, the source controller, notification controller, customized controller, etc. Just because this is going to take a minute, I can go ahead and jump over to a location where this has already been deployed. So actually, let's go over to find a research group here. So here in the deployments, there's going to be a few things that we see come up. One is the extension manager component that I just described, which is responsible for reconciling the extension. And then there's all the Flux components that are going to be brought to the cluster for the Flux extension to be appropriately deployed. So there's this Flux config agent, Flux config controller. Here's the Flux components that are part of the CNCF Flux project. And then once we deploy the configuration to the cluster, it's going to bring down the Nginx controllers. It should also bring down a Redis stateful set. So if we jump over here, we'd see Redis master and Redis replicas. And then it's going to bring down this pod info application. And so then if we were to also just like look at the pods individually, we would see the same thing. We'd see the extension deployed in the Flux system namespace, the Nginx controllers, the pod info, everything is deployed appropriate to the cluster. And we can make updates to this. I won't show it right now, but you can make updates to the manifests and they will re-reconcile in the cluster. So if you were to say push an update to this application folder, it would, to increase the number of replicas or increase the number of, well, if you were to push updates to the Redis folder and increase the number of replicas, or push updates to the application folder to increase the number of pod info replicas, it would re-reconcile those changes into the cluster, and you would see increase in pods and changes in pods in the cluster. And as Chris mentioned, again, if you go into the GitOps panel, you can go ahead and see the, or I guess in this case, actually, be this one. Go to the GitOps panel here. Yeah, and if you were to go into the GitOps panel here, you would see that the reconciliation state of that configuration and combined state of that configuration, so you can monitor it appropriately. So again, this one is still installing the extension, so we'll maybe come back to this one at the end of the demo. Actually, it just installed the extension, so we can come back to this once it's installed the configuration. Right now, I'm going to take a look at what using Bicep would look like to install Flux on a set of AKS clusters, basically to programmatically deploy AKS clusters, to deploy an extension, and deploy a configuration on top of them to kind of bootstrap a cluster with the applications you need. So here, what we have is a Bicep template that is essentially responsible for deploying 3 managed clusters. And just very simply, I'm going to name this cluster with Bicep cluster, and then the number that is assigned to it. It's going to get a system assigned identity, so it's going to be an MSI cluster, and just some basic information that's required in order for the cluster to be deployed. The other thing is we're going to deploy the extension on top of it, and it's very simple to deploy the extension. You give this Microsoft.Kubernetes configuration / extensions resource type. You deploy it on the managed cluster scope. You give it this Microsoft.Flux extension type, and that will deploy this extension on top of this managed cluster. And then finally, we're going to deploy a configuration, which is going to depend on the extension installation, and again, is also going to be deployed at the managed cluster scope. But it's going to look very similar to the one we just described. So it's pointing to the same repo. It's using a Git repository source kind. It has a cluster scope. It's deploying to the cluster config namespace. It's watching the main branch, and then some, again, a lot of the same information that we just described before. So again, we can kick off this deployment from this side. So all I need to do is do an AZ deployment group create to deploy to a resource group. We're going to deploy to the Bicep demo resource group, and we're going to reference this flux.bicep template file. And when we do that, it's going to go ahead and start kicking off this Bicep release, which again, this process, because spinning up AKS clusters takes a bit of time, is going to take a while. I'll go ahead and wait for it to start before we take a look at a pre-made one. Should begin to start up. Yeah, I saw it flash running for a second. But yeah, this is it's gonna start running and gonna take a second to kind of go ahead and provision the AKS clusters and provision the extension. Coming back over here, actually, we see that the configuration deployment to the AKS cluster that we originally started with completed. But if we take a look now at this Bicep pre-made demo folder where we've kind of already done the provisioning of the Bicep, what you will end up seeing once you run this Bicep template is you'll see 3 AKS clusters that all are going to have the things I just showed. Like, it's all going to have the Flux extension. If you go into the GitOps panel, they're all going to have configurations that are identical to each other. And what that means is you've kind of deployed AKS clusters using infrastructure as code and bootstrapped them with applications, which is really cool. And so now all of these clusters are pointing to the same repo, which means if you change things in the repo, again, it's going to change things across all clusters. And you can imagine if you separate out the repo into branches and you kind of describe either your different environments in a directory structure, or you describe your different environments in a branch structure, you can kind of slice out your large set of clusters into different environment assignments. So as you make changes across these different environments, they're going to change a certain set of clusters, and you can kind of describe like a safe deployment rollout or some kind of difference in configuration by kind of making these kind of tweaks and changes to your Git repository. Finally, we're going to take a look at the Azure Resource Graph Explorer to show a couple example queries and look at a bit of how you can view compliance across clusters. So here, we're just going to take a quick look at running an Azure Resource Graph query to get the compliance state by the cluster type. So right now, what we're interested in is we're interested in getting all of the Flux configurations in this pre-made demo resource group, which is the resource group that I just showed. And within this resource group, there are a couple Arc clusters, and then there's 3 AKS clusters using Bicep that I just deployed. So we have a couple different cluster types here, and maybe we're interested in seeing which cluster types are succeeding or if they're all succeeding. So we want to understand the compliance state of the configurations by cluster type here. So here we're looking at a specific application. So this application is going to be the Git repository that we were just discussing. Everything we're interested in Flux configurations that are pointing to this repo. And we're going to go ahead and parse out the cluster type and the provider, and then we're going to summarize the count of based on compliance state by cluster type and provider. So we run this query. Here we can see everything is compliant across our different cluster types. So here we have 2 configurations that are in a compliance state on the connected cluster type, and we have 3 configurations that are in a compliance state across the managed cluster type. So that's cool. That's interesting. We can look at a compliance state across different cluster types. But I think what's more interesting is you probably want to see what are the non-compliant configurations, maybe across your entire tenant or just across a single subscription. Like you can think about how to define these things in different ways. And you want to look into why is my configuration failing, and so I want to see which are my non-compliant configurations and which configurations do I need to go look at in more depth to understand like what is specifically wrong with either that Git repository or that cluster. So here we're looking at all the Flux configurations. We are taking the URL, whether it's a bucket URL or a Git repository URL, and we're keeping that in the URL variable. We're getting the compliance state from this, and we're going to check all of the configurations where they're non-compliant and get the information about those configurations. So here, if we run this query, right now we see there's a set of configurations that are in a non-compliant state, and these are the URLs that they're pointing to. These are where the resource groups are located. This is the configuration name, the cluster name. And so here, like for instance, we can take a look at, this is the ArcK's demo cluster, which is again another official URL. Another official Git repository that we use. This is the GitOps multi-tenancy cluster. So we can then go into these individual clusters and go into the GitOps pane, view the configuration objects that Chris showed, and kind of look at the specifics of why that configuration is failing to be able to debug it more granularly. So with that, kind of gone over the overview of how you can deploy configurations and the Flux extension and leverage GitOps in AKS. I'll pass it back to the AKS team.
Well, I want to say one little bit here before we open it for questions. I realized that when I was talking about the portal here, I was showing an Arc cluster, and my goal was to actually show it in an AKS cluster, but they look so similar that it's easy to get confused. Anyway, here we are in an AKS cluster, and you can see here the GitOps piece, and you'll notice here that it looks exactly the same as it does for an Arc cluster. So basically, GitOps works the same across all of the Azure Kubernetes types, and again, you can manage the configuration the same. One of the things that's really cool that released first in AKS, I love it, is this resources browser. And you can see here, if you filter by the namespace of Flux system, then you can see all the agents that were laid down associated with the Flux extension. So with that, we can open it up for questions. Also, there are some questions in the chat. One is about ARM templates. yes, you can, we all start with the core API. So you can use ARM templates to deploy the extension and Flux configurations. We are we're currently working on the Azure policies, which of course include an ARM template, to be able to install the Flux extension and the Flux configurations. And we should be able to release those sometime in July, I expect. We're also working on, as part of the product launch readiness, you need to have a PowerShell module, you need to have Terraform. We're still working on the Terraform piece, and that should be able to be done by the end of July, I believe. So you can use Terraform module as well to enable these capabilities. So I'll just open it up for questions then for Johnathan or myself. There's no provider for Terraform yet, that's right.
And Chris, is Dave. I know there was mentioned a few times about using other type of GitOps agents like Argo CD. Is there any plan to run that, or?
At this point, we have no plan to first-class Argo CD. Customers are totally welcome to use it. Our goal right now is to advance our implementation of Flux so that the characteristics of Argo CD that customers like, we will also enable within Flux within Azure.
Okay, great.
But one of the things,
and I expect a lot of that is around, probably, at least from what I hear from customers, is around Argo's more UI experience.
Exactly. Yeah. And there's even some aspects of the UX that they like. And so we've talked to customers who like Argo CD, Azure customers, and gotten their take on what they like. So we're going to be working on that as part of our roadmap. Another thing that we're working on, Johnathan has a spec on it right now. It's high value work for us, is to make it very easy for customers to create the Git repos and create a CI/CD pipeline, say using GitHub Actions, so that they can have a differentiation between the cluster admins and then the various app teams, and also then to be able to have a rollout strategy, an RDP, like rolling out to Canary and then rolling out to other groups of clusters in a safe way. So that's work that's happening today.
Great. That sounds like a really good feature.
Awesome.
Is anybody else have any other questions for Johnathan and Chris?
Yeah, I do. Hi, thanks for the presentation. I'm Roger Sass with Avanade. Just curious, once Flux is deployed, in addition to the AZ, I guess CLI, the extension, can I use just regular the Flux CLI to query and view sources and customizations?
Yeah, you can. There's full support for the Flux CLI as long as you have kubeconfig access.
Okay. Is there any downside to that? Do you recommend it, or what's the kind of position?
No, I would say there's not downside to that. I mean, I think the great thing about us working with Weaveworks is that we've kind of supplemented the work that they're doing. So it's like we want to come alongside them, and obviously everything that they're supporting, like they have a lot of active work in that area as well. So we don't want to kind of diverge from those things. So I would say, yeah, use the Flux CLI. I use the Flux CLI a lot.
Okay.
It's an incredibly useful tool as well. Yeah.
Right. No, I think it's just for clients that I'm working with that are used to it, it'll ease the transition. So that's great. Just, props and kudos, though. I think the whole idea of having this being a first-class citizen and being, supported, and particularly the operational aspects like the upgrading, I assume. How maybe you can talk a little bit more about the upgrades. Do they occur like when I do a Kubernetes in place upgrade on my cluster, or what is the process for keeping Flux up to date?
Yeah, so currently upgrades are driven by the extension platform across different cluster types, whether that be AKS, Arc. Extension platform is currently growing. So there's kind of two ways to manage extensions right now in terms of the upgrade path. There is disabling auto upgrade and kind of manually doing version upgrades by calling the API directly. Or there's enabling auto upgrade, which right now there's not a configurable time frame on which auto upgrade would occur. So auto upgrade is kind of happening. It's kind of driven from the extension, well, the extension owner side. So in that case, us, like as we push out updates, they'll be auto upgraded on your side. There is a feature down the roadmap that has to do with, setting a time window, a customer driven time window to, install the extension updates. But right now it kind of happens out of band without,
I see.
your explicit defining when you upgrade the extension.
Okay, yeah, that maintenance window capability is going to be really important for our production usage. So I'm glad it's on the backlog, anxiously awaiting. Cool. Thank you.
Just one question regarding the Flux. You mentioned that Flux doesn't have this UI capability, right? So how can we restart a service or delete a deployment from Flux? In that case, should we be using CLIs for all of these?
Deployments. So I guess it depends, right? So most of the time when you're making, you're doing deployments through Flux, right? It's kind of this continual reconciliation model where you are pushing changes to your Git repo and then it reconciles. I assume you're talking about like on-demand reconciliation from Flux. Right now, the only supported way to do it is, to use like the Flux CLI, Flux reconcile command to kind of on-demand reconcile the configurations. There is work in the backlog as well on driving that through Azure and driving it through ARM gestures. But it's currently not there. So you would have to mainly do that kind of on-demand reconciliation through the CLI.
Okay.
So one of the things that we noticed, say talking with SKF folks who are using Argo CD, is that one of the features that they like is, and the Weaveworks folks call this ClickOps, where a customer is, the team is able to look at what the diff is between what's in the cluster now and what this latest PR is going to change, and then the ability to look at that diff and then decide to push a button and say go. Okay, that same capability can happen all the way back at your Git repo when you're doing your pull request and the review of the pull request. You can then see the diff, and at that point, before the merge, you can decide whether to merge or not. So in a way, the Argo CD UX has made that a little bit more visible. It's sort of detached it from the Git repo, let's say, but you can perform the same action, as far as I can see, in your Git, your PR management in Git. But it is interesting that some customers really are a little bit unsure about the automatic deployment mechanism that goes with GitOps, and feel comfortable with the idea of wanting to see what's going to change and then push a button to say yes, go ahead and change it. So we're taking that feedback and looking to see how we can implement that kind of capability with Flux.
Yeah, even Argo. Sorry. Even Argo has that flexibility to see the events and logs, whatever the Kubernetes emits from within the cluster, right? So it can be very much useful in the case of troubleshooting. So Argo can reproduce those events for us in the UI as well.
Yeah, exactly. I mean, this information is there, and we're going to do work to figure out how to surface that. Currently the compliance is surfaced in Azure. So you get the compliance of the clusters and the ability to use tools from the Azure ecosystem like Azure Monitor and Azure Alerts. But yeah, you're right. The next step would be to how to surface things like the events and the logs easily to the customer. If there is a problem, if a cluster is not compliant, Johnathan, you want to talk a little bit about what info comes back to Azure in that compliance info drill down if a cluster is not compliant?
Yeah, I was actually going to say, I can maybe pull up a cluster and try and take a look at one. Unfortunately, everything is succeeding on my side, so yeah, so I can't bring up one very quickly. But yeah, basically, when you, I guess I can show a succeeded one, and we can take a look at what kind of information you get from there, and then what it might look like in the case of a non-compliant state. When you drill into the configuration objects, you can click into here, and you'll get some of the conditions that come back, which are typically pretty verbose about why it's failing. So typically when something has a non-compliant state, these conditions will describe pretty well from the Flux team, like why exactly the configuration has stopped working, why that specific object is not reconciling. So right now, this is kind of you have to dig into it by looking at the individual details and digging into either the UI or the CLI and our APIs to dig into like why specifically what conditions are failing. So multi-cluster, it becomes a little bit more difficult, I think, right now, which is something we're thinking about as we're looking at observability and like what Chris described, just making this a little bit easier when you have thousands of clusters that are not reconciling in some way. But right now, yes, you can dig into the configuration objects, dig into compliant state, non-compliant, and then view conditions here to see specifically why it's failing.
Yeah, this is really good feedback though, because this is what we want to make as a great end-to-end feature set within Azure GitOps. One of the reasons why Flux was chosen is because Flux doesn't require a master cluster like Argo CD does, like some of the other solutions that use GitOps. It's all individual clusters. And so what we're trying to do is run with that approach and make sure that everything can work in that sort of disconnected state, where basically the master is your Git repo. And then how to build on top of that within Azure to give you some of these capabilities, for instance, of the observability across groups of clusters, across applications that are deployed to multiple clusters. So that's part of the work we're doing to make this first class.
All right. We're right on time today. I want to thank Johnathan and Chris. Great presentation and demos here, and want to thank everybody for all the questions and interaction today. As always, feel free to reach out to us with any feedback you may have, any sessions that you want to see. We're definitely open to if anybody wants to present on this call. So always feel free to reach out, and thank you for joining today.